Let's see this question. We want to find the equation of the line passing through these 2 points. Right, so this is a 3-dimension points. So usually we see the first component is x value, second component y value, third component z value. Right, if we call this the first point, we could use x1, y1, z1, and we maybe call it the second point, x2, y2, z2. So in algebra, we know give us 2 points in 2 dimensions. Let's say 0, 1, and 1, 0. And we can find a line in 2 dimensions, right? We can find the slope. Then we can use the slope point formula or slope intercept formula to represent the line. But this is a 3-dimension. So what do? We want to use a vector idea. So we want to use a vector idea. So what does a vector mean? Let's say a 2-dimensional vector. If you give me a point 0, 1, let's use a better example. Let's say 1, 1. Right? If I have, let's say this is the 1, this is the 1, this is the x-axis, this is the y-axis. So I have point here. That's a 1, 1, x value is 1, y value is 1. And I can look at this as a vector. So it means I can draw a line from the origin to this point. Then the direction is, the origin is the initial point, and this 1, 1 is endpoint. So this is called a vector. So this vector has initial point, endpoint, has a length, and has a direction. So we're going to use the vector idea, right? So these 2 points we can treat as vectors. From 0, 0, 0, from the origin, right? 3 dimensions, right? Then connect this point 0, 1, 1. So just imagine a vector flowing in 3-dimension coordinate. Right, so we're going to use this vector idea to represent a line passing through these 2 points. So how to do that? We have a formula of a line. We see a line passing through a point we're going to call L of t. What does it mean? Imagine I have a vector, right? This is starting point. Think as t as a time, right? Think as an object, right? Going along this vector. So at a t time, at t equals 1, maybe come here, t equals 2, maybe come here, so on and so forth. That's why we use this such t here. So you see, okay, the line in terms of t equals to the initial vector. Initial vector plus time t multiplied by the direction vector. So we need 2 vectors. Initial vector and direction vector. Right? Initial vector, we can think as a point, and this point, like when we connect from the origin, that's a vector, the initial vector. Then we need t is a variable, we need a direction vector, shows, okay, it goes this direction, right? Or the other direction, any direction. So we need those 2 vectors. So we're given 2 points here. So we can treat any one as the initial point. Let's say we treat the first one, x1, y1, z1 as the initial point, initial vector or initial point. So sometimes I use two different terms. Let's see this point. Maybe 1, 1, 1, right? One way I can call it a point has an x value, y value, z value. Another way I can treat this one as a vector. Starting from the origin and at this point 1, 1, 1. Right? So basically any point we can treat as a vector. The initial point is the origin. All right, so let's treat 0, 1, 1 as our initial vector and this variable t. So where do we get a direction vector? And direction, you see this, we have an initial point here. We have an end point here. When we subtract these points component-wise, so this x component is y component, z component, component-wise, we get a direction vector. So which means if we're treating 0, 1, 1 as initial point, then 1, 0, 1 will be endpoint. So using 1, 0, 1, subtract 0, 1, 1. How do we subtract these 2 points? We subtract component-wise, which means we subtract 1 with 0, so 1 minus 0, which is 1. The second component is 0 minus 1, we get negative 1. Then 1 minus 1, we get a 0. So that's our direction vector. So that's it. So we can use this, right? So basically the addition of 2 vectors to represent this line in 3-dimensional space, passing through these 2 points. Or if we want to simplify, we can simplify this representation a little bit, right? We can add those 2 vectors. So first, so t is a real value, right? It's a scalar. We can multiply inside to each component of this vector. So 1 times t, we get t. Negative 1 times t, negative t. 0 times t is still 0. So we have these 2 vectors. And with 2 vectors, we can add them component-wise. Add 0 to t, we get t. Add 1 to negative t, we get 1 minus t. Add 1 to 0, still get 1. So it's a vector. All right, so in higher space, in higher than 2-dimensional space, so we represent a straight line with the idea of vector. So the line passing through these 2 points, 0, 1, 1, and 1, 0, 1, we can represent with line L of t equals t, 1 minus t, 1.